Okay. Hello everyone. As like all of you know what my project is, so I have made some updates here. Right now, I wrote the code just for like three participants. So I've like just chosen three participants and tried to run the implementation, and I'll actually show you how it works. So yeah, so this is the initial group key that we agree upon. Then here are the here, this is how the lattice will work. Like it is not in three dimension right now, but I can show how the updates will work. So we start from the origin and say out of the three participants, randomly one participant has updated the key, and yeah, so yeah, here you can see that the new index is 010, the key hash is this, and the lattice is right now from 000 to its 010. Now this will keep happening randomly. So yeah, so now say from origins, we move to 010, then the third participant updated the key, and then the second participant updated the key again. So this is the how the keys will be updated, and these are the messages. Like I just wrote random messages, which is the random text messages that everyone can send to each other. Then this is for like for first cycle. Then similarly we can have more cycles. So from 0 to 1, third participant updated the key again, but still the first participant hasn't. So this can happen randomly among all the participants. And yeah, so now okay, so now cycle 2 is complete. In cycle 2, the new index is at 022. This is the key hash, the new group key, this one. And wait, uh, yeah, so now this is the lattice state for like after the two cycles. The initial key was this, then the participant 2 updated, then the third participant, and they keep on randomly updating the key. So the group key keeps on updating, and these are the random messages that I've just added for to show that yeah, they can message to. And then maybe yeah, so I update from this to this to this to this to this. Now still participant 0 is not updating, and but still the other two participants are. And like this, I have used a random function, so any of the participants can update automatically, because I'm just running a simulation. But in real life, like when the participants are in the chat, they can run their own automations. And uh, yes. Mm, yeah, so yes, this is one more update, and I think it should be done now. Yep. So yeah, so like I wrote it for four cycles. So final, this is the final like lattice state for every participant. For participant 0, this is how it updated for participant 1 and for participant 2. So this is the final group key for after the 7 updates. In this cycle, like the participant 1 didn't update the key, but it's all random. So like if I'll run the again, so there will be some different updates. But yeah, like this is how it is working for now. Like my plan is to update it to for n participants. So there's something called a convex hull. So like yeah, for forgetting and for answering the queries, for when I like move to say like n number of participants, maybe 100 or 200, like this brute force can work for 30 or 40 participants. But when I implement this, I have to read about it, and after this, like it should be good for other participants, like if n is very large. And yeah, this is my future plan. So no. So, like this is that for forgetting, we can either use brute force if the number of members are very less. But if n goes more than 60 or 70 or 80, then there's something called convex hull which we implement. So it gets relatively easy for large number of people. So yeah. Yeah.
Uh, does participants need to store all the coordinates of the lattice or only
No,
the most
no.
important
So
ones?
right now I've implemented the forget function, but like I haven't shown it in the simulation because like I have to test it out. But yeah, there's a forget function, and wait a minute. Uh, so yeah, this is the forget function, and like the keys, there is a window parameter called w, and before w those keys will be redundant, they will not be used, so every participant can delete those keys and move forward to like limit the storage space.
I see. And the convex solve is a more efficient implementation.
Yes, 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 yes. Any other doubts? Okay. Okay, thank you. Yes.
There is another one that is only at 10 to 40, but if they are already Mizuki Kusan? No?
Oh yes, sorry.